Hi, this is a presentation first project of statistical inference. Our groups contains 4 members. They are Cao Tianyu, Chen Zheyan, Qiu Rui, and my name is Chen Chen. The paper we're going to talk about today is Bayesian hierarchical model for prediction of football results. The statistical question of it is estimate the characteristics that brings a team to lose or win in a game, and to predict the scores of a particular match. The data they use is based on the Italian Series A 1991 to 1992 championship. Also, after dealing with an overstrinking problem, they further test the model performance by using the data of Italian Series A 2007 to 2008 championship. Let's look at the data. So in the Italian Series A 1991 to 1992, there are all together 19 teams, and the total number of games is 306. In the G scheme, YGJ represents goals scored, and J equals 2 represents home team, J equals 2 represents visiting team. HG and AG are just index implied in the team name. For the YGJ, it assumed follows a conditionally independent Poisson distribution. YGJ follows a Poisson distribution with parameter theta Gj, and theta Gj is assumed as a log linear random effect model with home, attack, and defense. Home is a home advantage, attack and effect, defense is attack effect and defense effect. So let's look at the priors of this model. Here they use a normal. They denote a normal distribution by mean and precision, and choose a zero-sum constraint. The priors are all assumed as uninformative priors here. So the graph that's provided in the paper shows that the authors first try to estimate those parameters by the observations, which leads to the theta G1 and theta G2, which implies the distribution of YGI, YG1 and YG2, the scores. Okay, so in the objective of the modeling has twofold. The first is estimation. They try to estimate the values of main effects by means of Bayesian's theorem using a MCMC Markov chain Monte Carlo based procedure. And this is a result of the estimation, the distribution of attack effect, defense effect, and home effect. Notice that the home effects are all positive. The second flow is a prediction. In this graph, the black line represents real observations. The blue line represents a prediction of our model, the hierarchical model. And the red line represents prediction of bivariant Poisson model. And as can be seen from the graph, at most of the situations, the blue line, our model performs better than the bivariant Poisson distribution.
A possible well-known drawback of Bayesian hierarchical model is the phenomenon of overshrinkage. In this particular case, which is predicting football results, it can be particularly relevant, as presumably some teams might have very good performance while other teams might have very poor performance. The author point out that the hyperparameter they used in last model might not enough to capture the presence of the quality of the teams, therefore producing overshrinkage with the effect of penalizing the extremely good teams and overestimating the performance of the poor teams. Therefore, to avoid this problem, few changes have been made. Firstly, the non-central t-distribution instead of normal distribution is being used to model the attack and defense effects, while the prior specification of theta Gj and the hyperparameter home are unchanged. Also, in order to capture the presence of quality in each team in each team T, two latent variable, group attack T and group defend T here have been introduced, identifying the bottom, mid, or top table teams in terms of attack and defense. Now, the attack and defense effect are that model for each team T with these two non-central T distribution. Moreover, the model for the location and the scale parameter of the non-central T distribution is specified like this. Then, Italian Series A from 2007 to 2008 has been used in the paper to compare the performance between the basic model and the mixture model. Some differences worth mentioning between this season and the one in 1991 to 1992 are the ring is now worth 3 points and there are 20 teams. Therefore, the total number of games is now 360. A table have been presented for validation of the model. It shows the estimate final table in comparison with the one actually observed. As we can see, even though the estimate of the number of second of score and conceded goals are generally very much in line, there are differences we can notice. In fact, when using the basic model for the data, a large overshrinkage was produced, penalizing in particular Intel and Roma with overall 85 and 80 points in the final table. The estimated points for the basic model was only 69 and 67. Similarly, the bottom table teams were predicted to have significantly more points than the observed, while the mixture model has limited the overshrinkage. Overall, the Bayesian hierarchical model shows better performance in predicting football results.
So now we're going to talk about the replication of these example in the paper. And since the paper has not specified what the parameters are, we're just going to use the 200,000 iterations and 40,000 burn-in and 20 as the thinning interval. We also made some simplification here, just assuming that the team-specific attack effects and defensive effects are following zero mean normal distributions. Since if we did not do that, we actually had some autocorrelation issues in the MCMC process. So that's kind of like a shortcut. And if we check the diagnostics after the MCMC process, we have pretty good estimations. Here we have no autocorrelation problems, and also the HPD interval does not include a zero here. Also for tau attack and tau defense. After that, we're gonna just look at the average attack versus average defense plot, since we're not gonna really look into the 20 team-specific attack and defense diagnostics. As we can see here, for some top teams, they're in the bottom right corner, and AC Milan is better in attack, but they actually did not make to the Champions League. Also, the HPD here, we see that the top 4 teams are standing out right there, possibly indicating some overshrinkage. Next step is to do the simulation. After one simulation, we have some new top 4s, which are not 100% incorrect here. But this is just one simulation, could be by chance, the result could be by chance. So just, let's take a look at the result after 1,000 simulations. Here we can see some underestimations for the top teams and overestimations for the bottom team. Probably this is a proof for the over-shrinkage. But one problem remains is that what are we really learning from this data? I mean, actually we are doing some forecast using like history data to predict history. So probably we can do something more, like inserting some new data and compare the results from different data sets. And this is what we're gonna do here. Like using the 2015 to 2016 Premier League data. And as we can see, so here are some very different attack versus defensive effect. Here for some mediocre teams, they're not very good in attack, not very good in defense, but they are safe here. But for those teams, if they're as bad as those teams in attack, but they have very bad defense, they're in danger of relegation. And for those top teams, they have both very good attack and both very good defense. But comparing with those teams from like 10 years ago in Serie A, here, we can see that those old teams, those Italian teams, they play pretty defensive style of football. But the English team, they're very good in attack and we're balanced. I'm here. So can we say that those Italian team, like from 10 years ago, are worse team comparing with those English teams nowadays? Basically, we cannot say that. 10 years has passed. Like a lot of things changed. The philosophy of football changed. Also, like aggressive playing style is more appreciated these days. So basically, we cannot have a conclusion by that. But we absolutely can analyze the playing style of football. So basically, that's all I want to say here.
Okay, let's move on to the existing attempts on the prediction. Not only the model analyzed above, but also there are actually many other famous attempts used to make predictions on sports results, such as the sabermetrics. The term is a combination of the SABR, the Society of the American Baseball Research, and the metrics, meaning the measurement. Defined variously as the search for the objective knowledge about the baseball and the mathematical and statistical analysis of the baseball records by the Beer James, who created the term sabermetrics. It has become more and more widely accepted as an evaluation tool. Besides, error rating systems as a measure of the team's current strength is used to create the covariates for the match result prediction models. It is initially developed for the assessing of the strength of the chess players, but has been widely adopted in various other sports, including association football. Recently, as a big data becomes popular, many models based on the machine learning has been developed to apply to the prediction of the sport results. Machine learning is one of the intelligent methodologies that has shown promising results in the domains of the classification and prediction. In general, these kinds of the models lose some interpretability but improve the accuracy of the prediction. The prediction models utilized to forecast the results of the competitive games plays a significant role in many aspects, such as the gambling and the coach improvements, as well as the journalists. Okay, let's move on to the conclusion part. To sum up, the paper chosen firstly used the data in Italian Serie A for the season 1991 to 1992 to fit a base model. However, due to the over-shrinkage, some extreme occurrences tend to be put towards the ground mean of the observations. A Bayesian hierarchic model was introduced to predict football results. Both the results in the original paper or obtained from our new data show some advantages of using Bayesian hierarchic model to predict the football results. The first is the Bayesian hierarchic model shows the better performance in predicting the football results and can be easily implemented and run using the standard MC algorithms. Moreover, the hierarchic model can be easily extended to include the mixture structure to account for the fact that the team shows a different propensity to score and goals as represented by the attack and the defense effects. In this case, the model can still be considered in the standard MCMC algorithms. Okay. However, actually, they have someone point out that the result produced by the model has some limitations and can be improved. One of the limitations is that the predictions are obtained in one batch, that is for all the G games of the season, using the observed result to estimate the estimators. It also suggests that a more complex approach to predict the new instance of the games. It can be better to include more variables like the injuries, suspensions, winning streaks, and so on to get a more accurate result. Okay, here is our reference list. For this part, actually, the analysis extends beyond the course literature through the examination of the reputable scholarly sources. Multiple sources are used to support the development of our presentation. Okay, thank you.